Okay, good morning or good after lunchtime, I guess, everyone. Um, Here's what's going to happen. So, since I'm not around and I want you guys to be able to kind of check everything that you're doing, what I'm going to do first is I'm going to go over the exercises and the homework from yesterday, just so you can kind of see what is going on with those. You can listen to me talk. You can skim through it. I'm probably going to do it the next couple days too, and but you could just skip through it and pause it and check your answers that way. Um, if you're feeling real good, then I would just fast forward in this video until you actually see the next lesson starting, because otherwise this is going to be real long and you're just not going to have enough time to do anything. So I would only go through this part if you really actually need to. And I'm also going to do things like I'm going to pause it and fill in stuff, and so hopefully you won't have to wait as I write a bunch of stuff out while I'm going through the lesson. So anyway, moving on. So with this first exercise, and again, if you don't need this, skip till you see the lesson. You had to fill out this table. This table is basically showing 1 nickel per container. So the expression is the number of containers times the number of nickels. The expression would be 5 hundredths times C, where C represents the containers, because each container you're getting a nickel, and a nickel is 5 hundredths of a dollar, and the table wanted it in dollars. So if you use that expression for, you could do 222 cans would give you $11.10. $4.50 if you divided that up by 5 hundredths to get the number, a nickel, you'd get 90 for 90 containers. And part D is different than part C because C is solving for the cans, D is C is solving for the money, for the amount of cans that you're returning, where D is the opposite. You're solving for the number of cans for the amount of money that you have. And exercise 2 is basically the same exact thing. It was actually, I think, a little bit easier because you don't have to think of it in terms of nickels. It's just dollars. So $2.50 per ride. It would cost $150 for 60 rides. $175 would get you 70 trips. And D and C are again different because one's solving for rides and one's solving for dollars. This one was, it's definitely a challenge problem. It is a little bit tricky. What you really want to think of is basically, if you're really trying to figure out how this worked, was that the cycles and the time in seconds are not multiples or divisible by one another. So you have to think of it in terms of kind of like a unit rate. And you could do that as a decimal, but it's actually easier to do it as a fraction. So you could think that, this, whatever this thing had to be down here, this expression was going to be the time divided by this, right? And you could just write it as an expression, 15 over 12, 15 divided by 12, times C. And this would actually be the same exact thing as, they get 15C over 12, because if you think, 15 over 12 times C, what's C as a fraction? Well, anything over 1 is itself. So 12 times 1 is 12, and 15 times C is 15C. So that's kind of how they get that. And it would be 20 seconds, and the opposite expression would actually be the reciprocal of this. So instead of 15C over 12 for the number of cycles, if you're solving for seconds, it would be 12 over 15 times S, or 12S over 15, like it says right here. I'm going to go to the homework real quick. I'm not really going to talk about the homework very much. I'm just going to kind of throw it up here so you can check it out if you need to. You definitely want to get help if you're having a hard time with like number 1 and number 2. The other ones are a little bit trickier, so I'll just throw those up here, and if you want to check to see if you did them correctly, you can pause it. there's the end. Okay, moving on to the lesson. Okay, so for this thing, this says the Italian. Actually, what we're doing today is we are writing expressions and evaluating them that have multiplication and addition. Obviously, you can't solve every problem in the world using just multiplication or just addition. So sometimes you have to use combinations. So this says the Italian Villa restaurant has square tables that servers can push together to accommodate the customers. Only one chair fits along the side of a square table. Make a model of each situation to determine how many seats will fit around various rectangles. Take a second on your own, because I'm sure you could probably do this faster than waiting for me to write all this stuff down. And I would fill out the first part of this table by thinking how many people can fit around each of these tables. So take a moment to do that while I fill it in. Okay, so you can see here I've filled out the table just by counting how many people would fit around. So are there other ways to think about solutions to this problem? You should be thinking, yes, we can make an expression to figure it out, because if you can't count around it, it's going to be too hard. Is it impractical to make a model of pushing 50 tables together to make a long rectangle? Probably. If we did have a rectangle that long, how many chairs would fit along the long sides of the table? So coming up here, what you want to think about is when you are counting, you essentially always had people sitting along the top of the table. You have people sitting along the bottom of the table, and then you have the two people on the ends. So regardless of how many people are sitting at your tables, right, whether it's 4 or 3 or whatever, you always have a person sitting at the top and the bottom of every table, right? Top, bottom, top, bottom, top, bottom, top, bottom, top, bottom. But then you always have two people on the ends. So I could kind of figure out how many that would be, because if you had a long table and there were 50, that would mean that there's 50 people up here, 50 people down here, and then you'd have two people on the ends. So how many chairs would fit on the ends of the long table? Well, that'd be the 2. Oh, and I forgot about answering how many chairs would fit on the long sides of the table. 50 on each end. And so how many chairs would fit in all? So that would be, if I go up here, it would be the 50 plus the 50 times, plus the 2 on the ends. So that's 102. And I would take a second, see if you can figure out with someone how many would fit around 200 tables. And then I will actually do that. So you could pause it and I'll come back in a few seconds. Okay, so I made this little diagram that you may have come up with. And so this little purple rectangle is showing I have 200 tables. And so that means if I have 200 tables, that means I'd have 200 people sitting along the top, one person at each table on the top, one person at each table on the bottom, and then I'd have 2 on the ends. So if we let T represent the number of square tables that make one long rectangular, what's the expression that we could write? Well, it's looking like I'm always going to have 2 times the number of tables, right? I have 200 here. Well, I've got that times 2, right? And then I always am going to have 2 people sitting at the very ends. So I could write, it's going to be 2, and I'm going to use a little curly kind of T. 2 times the number of tables plus 2 people. Okay, so this would be for 200 people, it would be 402 people, because 200 times 2 would be 400, and then add on those 2 people on the ends, you have that 2, and my expression would be 2t plus 2. Let's do another example right here. This says, and I'll give you a minute to try and do this on your own, but this says Pizza Queen has a special offer on lunch pizzas, $4 each. They charge $2 to deliver, regardless of how many pizzas are ordered. Determine the cost for various numbers of pizzas, and also determine the expression that describes the cost of having P pizzas delivered. So I would take a moment to pause it and try and do this on your own, and I'll come back in a couple seconds with the table filled out. But you should not be lazy. You should just do it yourself to make sure that you are getting the hang of it. Wink, wink. Okay, here it comes. So what I'm noticing is that it is $4 per pizza, right? So however many pizzas you'd have to get, you could figure out how much your pizzas are going to cost by doing $4 times however many pizzas you have. And that's what I've written down here through all these expressions. And then it's always just $2 to deliver. So if you're trying to figure out how much you would have to spend, you would do $4 times the number of pizzas. So in parentheses right here, I wrote my number of pizzas because, for this example right here, I'm getting 10 pizzas, so it's $4 times 10 pizzas, or for this one, 3 pizzas, $4 times 3 pizzas. And you'd figure out what that was, right? And then you'd have to just add the $2 for delivery. So this would be 4 plus 2 is 8, 4 times 4 is 16, plus $2 is 18. And writing it out like this, instead of figuring out that this is 12, kind of writing that, okay, I'm doing 4 times 3 pizzas, can kind of help me see that these are the numbers that are changing. So my expression would be 4 times the number of pizzas plus the $2. So the mathematical operations that we had to do to find the total cost was multiplying and adding. And this says, suppose our principal wanted to buy pizza for everyone in our class. Determine how much this would cost. So we could solve that by thinking, okay, how many people are in our class? We have 30 people in our class. So let's say everyone wants to have two slices of pizza, so that would be 60 slices. Now let's assume that each pizza we buy is going to have 8 slices. So we have 60 slices divided by 8, right? Because we got to figure out how many pizzas actually we need total. So 60 divided by 8, that's the same as like doing mental math, 15 over 2, which is 7.5, and you can't actually buy 7.5 pizzas, so we're going to buy 8 pizzas. So then it's $4 times 8 pizzas plus the $2 of delivery. So 4 times 8, 32 plus 2, $34. And then it says, if the Booster Club had $400 to spend on pizza, what's the greatest number of pizzas they could order? So you're actually not, you can't spend, if you're going to spend $400 on, like, let's say a pizza party, you have to think about the fact that you are always spending $2 for delivery. So you can actually only spend $398 on pizza if you want to be a cheap person and not give the delivery guy a tip for all that pizza too. So let's assume that the tip's built into the cost somehow, and we have $398 to spend on just the actual pizzas. So we would do that divided by 4, and 398 divided by 4 is 99.5. So you can't actually buy 99.5 pizzas, so we could just get 99 pizzas. And so here is another example of a table. And so take a second and try and fill this one out. It's basically the same thing, but a little bit different numbers. I.e., I'd pause it. So this one's very similar to the last. The difference is that the pizzas are $5 each, and the delivery is always $3. So that expression would be, we would be doing $5 times the number of pizzas, always adding $3 onto the end to get the total cost. So that would be 5p plus $3. And that's pretty much it. So what I'd like you guys to do, and girls, is problem set 1, 2, and 3 for your classwork, and then you can do the rest for homework. I know it looks super long, but I mean it's mostly filling in tables, so not that much work. Don't see a bunch of words and think it's gonna take you 3 hours. That is all. Have fun.